Another element of an organization's data architecture are the actual databases that store an organization's data. Over the past few years, different types of databases have surfaced to cater for the ever-increasing volume of data, special access scenarios and use cases, special storage requirements, and more importantly, to address the security and performance issues associated with storage and access of an organization's data. As there are various types of databases, it's imperative that one uses the right database for the right business problem. Different use cases drive the choice of databases, each of which is built on different technologies. For example, a use case requiring a large data storage for backup needs a different type of database than a database that requires real-time analytics use cases. Similarly, applications requiring data storage in non-traditional column-based structure will require different databases than the traditional relational databases. For the most part, organizational databases can be broken down into two categories. The first ones are the operational data stores that store operational data related to an organization's ongoing operations and processes. The second set of databases are used for data analytics and comprise of data analytics and data warehouses. The different types of databases that are available to help organizations build digital and cloud solutions include relational databases, in-memory databases, document databases, graph databases, key value databases, time series databases, and there are other kinds of databases with the different technologies. We will cover each of these databases briefly in the next slide. So although databases have been around for many decades, they have evolved to cater for the applications of each era. And lately, and to cater for the digital and cloud applications, databases have incorporated a number of features. Let's review some of those to help us understand the capabilities of those databases. So, for example, to cater for AI and machine learning use cases, databases are building features and capabilities such as building more efficient query processing to help with those use cases. They are building support for containerized applications and how containerized applications access data. To better manage the increasing data volumes, databases are building better compression techniques to help control the increasing storage requirements. New databases also have reduced operational overhead due to built-in features and capabilities such as automated troubleshooting and administration. Due to the increased need for continuous availability of digital and cloud applications, databases are building better availability features to help reduce downtime. For example, most databases now have native replication built in their database engines to help with increased availability. They're also building better performance features to deal with the queries from multiple digital and cloud applications and clients requesting access to data. They have incorporated better user interfaces, such as including support for faster logins, faster access, better administration, automation, etc. These newer databases are also being built to handle requirements for complex and heavy-duty workloads that work across multiple availability zones and work across multiple cluster deployments. Our databases are also incorporating NoSQL and other cloud-native technology features. As a reminder, NoSQL means not only SQL or non-SQL based data stores. And these types of databases became popular with the implementation of big data solutions. The reason that these solutions are classed separately as big data solutions is that they can store both structured as well as non-structured data. For this reason, the databases used for big data are also referred to as NoSQL databases. Finally, we can say that new databases are now purpose-built for the cloud and not for static environments. As we had highlighted earlier that it's important for organizations to select the right database for the right use case. This becomes particularly important in large cloud and digital solutions that may have a number of use cases embedded within the larger cloud solution. So selection of databases becomes quite important. Here we'll cover some of the different databases and their types, their uses, and examples of those databases. Relational databases. Relational databases, or RDBMSs as they are called, are one of the most common and oldest type of databases and are used for system of record types of applications such as ERP systems. In these databases, data items are conceptually arranged in columns and rows with specific relationships between them. They are usually used for transactions where there are requirements for ACID compliance. ACID stands for atomicity, consistency, isolation, and durability. The ACID test ensures valid database transactions in that transactions are not left hanging in the middle when committing to a transaction. Applications that require ACID compliance usually opt for relational databases. They are traditionally used in applications such as ERP systems and data warehouses. Examples of RDBMSs are Oracle, MySQL, and DB2. In-memory databases store data in memory rather than on disk or SSD or solid-state drives, thus making them very fast. They are ideally suited for high-performance applications which require very low latency. They are ideal for use cases such as gaming applications, geospatial applications, etc. Examples are MongoDB, DynamoDB, and Cosmos DB. As the name implies, for document databases, these databases store data that are represented as documents and where data is semi-structured. Data is stored as documents where each document is made up of fields and object data values. These databases are therefore NoSQL databases. The interesting thing in these databases is that not all data need to have the same structure. Examples of document databases are CouchDB and Firebase. Graph databases are built on graph structures comprising of nodes and edges. The nodes refer to entities and edges represent relationships between data. The data in these databases thus can be visualized as graphs and are ideal for use cases where data have a lot of interconnected relationships. They're ideal for social networking and recommendation engine types of applications, and also for fraud systems and geospatial systems. Examples of these databases are AllegroGraph, Infogrid, and Neo4j. Key value databases are non-relational types of databases where objects are stored as key value pairs and do not have a predefined data structure. A key is an identifier and is paired with an associated value. They can store all types of data and are used in high-traffic web applications such as e-commerce and gaming. Examples of these databases are Cassandra, Redis, and DynamoDB. Finally, time series databases are optimized for use cases that require time-based sequence of data. As they capture a lot of data, they are optimized for write operations. For example, that happens with data ingestion use cases. Examples of these databases are InfluxDB, KDB+, and Prometheus. Although these are some of the database types and technologies of the ones available in the market, but we can say that most of the cloud-based solutions end up using one of these types of databases.